Okay, no, don't say anything, but I'm a little concerned that not everybody knows where everything is for this course, okay? Uh, uh, Partly because some of you are only here for one class so far, okay? And some people missed the first day and then missed last Thursday. Now, hopefully you've been seeing the videos and keeping up, okay? As you're required to do that if you're not in class. Fortunately, the stuff we've done, now last Tuesday, a week ago today, people did really, really well in class. It was really good class. Thursday, it did not appear that people had followed up the class very well. Okay, some were better than others, but yeah, you do have to follow up if you're not here. So it could be that some of you are a little bit behind. You're going to need to catch up. Now, how many got my email saying there's going to be a test next Tuesday? Okay, everybody checking their email? Okay. Now, I might end up having to move that test back a little bit as I look at what's been done. If I move the test back, that just means we have less time to cover the rest of the stuff. Okay. Stuff we've covered up till now is pretty much what we did last Tuesday. Okay, but you got to really have that nailed. Every day you got to have it nailed. Now, between Tuesday and Thursday, short time, so you've got to take extra time to nail it over the weekend. Okay, because you have 5 days between Thursday and Tuesday, only 2 days between Tuesday and Thursday. So make sure you're doing that. This stuff right now is not difficult. You just have to do it step by step. So you're going to need to kind of catch that up. How many got that email? Okay, so you got it. Read it carefully. Make sure you know what it says. Also said today we'd have a quiz. I'm going to start with this, but then we're going to come back and we're going to do that quiz, that 6-minute drill, see if you can construct all these graphs. Okay. And if you can, you're doing fine, but there's some stuff we did Thursday with function notation. Okay, so what I'm really doing is kind of quizzing to see how well you pick that up, and we'll go over it again quickly. Okay. Now, also Thursday, I introduced the graphs of the reciprocal square and the cubic function. So you're going to need to get that from the video. So now my question is, how many people know where the videos are? Okay. Now, if you don't know where the videos are, you just simply need to go to the Canvas and read the welcome announcement where it says, okay, we've got a question here. Hang on. Okay, some people are mentioning a 404 error on something on the welcome announcement. So I'll have to go into Canvas and see what's going on there. Of course, if you run into that, or run into any kind of a glitch like that, you should immediately email me. That way I can fix it or tell people how to work around it, okay? And I'll tell everybody, if somebody's having difficulty, I'll send it to everybody. But some people did email me. So some people managed to get it to work, but as I was just told, there's kind of a workaround for it. Not everybody's necessarily going to get that workaround, right? Okay, well, the big workaround is make sure you know where the assignments page is and have it bookmarked, okay? And then read everything on the assignments page, because day by day, it tells you what you need to do. And there's stuff that's not in Open Math right now. Okay, we're not really using Open Math yet. I've scheduled your first assignment for Open Math to be due on Monday, but I might move Open Math back a week. I've got flexibility in the schedule to do that. I don't want to do that, but we've had a lot of confusion getting started. Okay. A lot of people didn't make the first class because of a snow schedule. It might have messed with your work schedule, or maybe you had a long driveway, it was uphill both ways, and it's probably still frozen. Okay, whatever. If you weren't here the first day, yeah. Now, if you happen to also miss our last class, that's where you really need to go to the video, right? And I don't think you'll have any trouble. From what I saw in class last time, people picked up really quickly. And I think y'all are overall a good group here. And I think you can do quite a bit, do this course really well. Okay, so basically get caught up. And yeah, I'll say more about how we're gonna do that, but let's dive in. Let's see what you got here. Let's see how well you can answer these questions. Okay, so you did pretty well with this, but most of you didn't know how to construct this, or didn't remember how to construct this, because of course, almost everybody did a good job of constructing it a week ago. And that's what I mean by follow-up. If you learn something in class, then you review it and you make sure you know how to do it when you come in the next time, just don't get quizzed on it. And because you need to know it so you can build. And if you don't know it, then it's gonna go by pretty fast, okay? Because you're gonna just have to review it. And I can't reteach what we did before. We don't have time. We're already behind on schedule because of the snow days. Right at the beginning of the semester. It's a terrible time to have that. Okay, anyhow, and with that, let's see. First of all, f of x equals 2 to the x. So f of x minus h is 2 to the x minus h. That should just make sense, but it doesn't always. It depends on how your brain's wired and stuff. You look at this as x has been replaced by x minus h. Here's your definition of the function. You replace all the x's by x minus h. You replace one by x minus h, replace them all by x minus h. Okay? So we replace this x by x minus h, we replace this x by x minus h. And that has the effect of moving the graph h units in the horizontal direction. Okay? So that our vertex ends up with x coordinate h. So for example, for this graph here, what's the x coordinate of this point? Show, well, you can't really, I'll let somebody tell me. How many of you know can tell me what the x coordinate of that point I just drew is? And let's put a red dot there, because that's our red dot that we've learned to love over the last week. Okay, so what's the x coordinate of that red dot? Okay, so, put the red dot here. What's the x coordinate of this? Well, it's halfway between -16 and -12, which is -14, right? So in this case, h would be -14 and x minus h would be x minus -14, which would be x plus 14, right? So we'll apply that here. But of course, this function isn't 2 to the x. This function is the square function. This is the exponential shape, okay? Anyhow, there it is. Now we're trying to get a f of x minus h plus k. Okay? And we've figured out what x minus h, f of x minus h is. So a f of x minus h plus k, as soon as we get f of x minus h, we just write out the rest of it. F of x minus h is replaced by this expression now. So where we had f of x minus h, we have 2 to the x minus h. It's not complicated, you just got to get used to it, okay? It's a substitution, which should be fairly natural if you have algebra 1 and algebra 2, okay? All right, so there we have it. And that's it. I'll take the word is replaced with an equal sign. So now there's, it goes in place of the question mark. Now, we pretty much understand that? Should be pretty clear. But function notation is always a problem for people. Okay. Now, I've been pointing to things that don't appear to be visible on the screen. But they're visible now. Yeah. There's some stuff behind it. It's hard for me to see what's over there. Okay. So f of x equals 2 to the x, that's how we get a f of x minus h plus k. We first do f of x minus h, substituting x minus h. Put x in the definition. We get this, and then we just write it out. Okay. Now, gonna need a little more room to do this one, so I'm gonna redraw it. We got y equals 32. So when does it do to us? Let's say y equals 32. And x equals negative 16. And x equals negative 12. Now we're doing the squaring shape inside this rectangle. So what do? Well, first we put a red dot at the lower midpoint of the lower edge. And then we do our subdivision vertically. We cut the rectangle in half. Okay. Then we subdivide this rectangle halfway, and then halfway from here to here. And we do the same thing on the left. And there it is. Okay. Now, these here should be twice as close together as these are. And we're going halfway. So make sure you know what halfway means. Okay. And some people are, a little, I can't always tell whether you're thinking halfway or not. Like you put all these lines and make them equally spaced, we haven't done halfway. Okay. And if I can't tell that this is about twice as far as this, or this cuts this rectangle in half, if it doesn't look plausible, then you probably have to penalize it. And well, now we upper edge, we go halfway, then we go halfway toward the lower edge, then we go halfway, then we go halfway, then we go halfway again. I've done this several times. I'm not going to explain it now because we don't really have time for detailed explanation. Okay. Now, some of you did well with this. Okay, we want to label these construction lines. What's y equal to here? 24 here, 32 here. This is halfway between 24 and 32. What's halfway between 24 and 32? 28. You can check that. From here to here, it's 4. From here to here, it's 4, right? Then we cut that in half. Well, halfway between 24 and 28 is 26. Now we're going to have to label a couple of these over here because things are getting squeezed over here. But this one is then going to be, well, halfway between 24 and 26 is 25. And halfway between 24 and 25, 24 and 25 is y equals 24 and a half. I really don't want to see 24.5 unless first I see 24 and a half. I want to think fractions because we need to think fractions for many, many reasons as I've explained. Okay. Now, and I said negative 16 to negative 16, it's negative 16 to negative 12. So now we can label our x lines. This is x equals negative 14, as we saw. Okay, halfway between negative 16 and negative 12. Then halfway between negative 14 and negative 12, Oh, that's easy, that's -15. Halfway between -16 and -14, that's easy, that's x equals -15. And then these two lines, let's get a little cluttered down here, we'll label them up here, this is x equals, what, halfway between -14 and -13 is -13.5. That's this one. And x equals -14.5. Here. Then we say, okay. That's it, we constructed it, and by constructing, that means we label it as well. I'm giving you easy numbers right now, and then you get harder numbers, you know, if this is 48.7 and this is 326.8, you're really gonna have to use your calculator to figure out what's halfway. Not that you couldn't do it by hand, it'd be ridiculous, unless you do it in your head. And I wouldn't want to do that in my head, I don't know, I could, okay? I'd resort to something or just do an estimate, depending what I needed to do. Okay. So there we have it. Now we have to construct our graph, of course. So we start in the upper left, we go over 1 down 2, we go over 1 line down 2, we go over 1 line down 2. And then we do it symmetric with the other side, or over 1, up 2, over 1, up 2, over 1, up 2, whichever way we want to do it. And we get. That might be pretty good parabola. I don't know, maybe the stars aligned and I did a good one for once. Okay. Don't want to brag. I'm somewhat proud of that. Because I'm really pretty bad at drawing these on the board. Okay. Not all that proud, I can do. Now. Want to estimate x if y is 27. Oh, here's the line y equals 27. Clearly, if you know where 26 and 28 are, you can find 27. And then we see that there's a graph point here and a graph point here. And we project down here. And we project down here. And we say that this line here, this point here, well, what do you think? This is -15, this is -16. This is a whole lot closer to -15 than it is to -16, right? So I'm going to estimate x equals -15.2. That's here on this line. Notice we don't have an x-axis or a y-axis because the x-axis is a few feet over this way. Well, maybe not a few feet, it's, you know, yeah, I'm sorry, it's over about here. And the y-axis is down through the floor. Maybe not that far, 1, 2, down near the floor, okay? And we can't draw it. No point in drawing it. We know where we are because we've got these things labeled. We're totally oriented. We know the origin is over there somewhere, okay? All right, anyhow, now we estimate this. Now by doing an honest estimate, I think that this is between -13 and -12, closer to -13. I'll say x equals -12.7. Although if everything is symmetric, either this ought to be -12.8 because you got a 0.2 here, or this should be -15.3, so they would be equal distances on the other side, on the two sides of the center, because you have a lot of symmetry here. Yeah, from -14 to -12.7 is 1.3. From -14 to -15.2 is 1.2. This distance wouldn't be 1.3 if this distance was 1.2. I'm just being honest with my projection lines, which I'm always totally accurate. Now, I don't know which one's going to be better. I think it's going to be pretty close, but we're going to find out. Okay. Now, what do we do with this? And this is where we start into the stuff we really want to talk about today. Okay, before I go on with this, we'll come back to this example in a minute. You got it pretty firmly in your head. hopefully. I just want to tell you a little bit about where this is heading and why we're doing all this. Okay? In the MDE 61 today, we went over transformations. And you should find it easy to understand what we're doing because of the graphs we've constructed. If you haven't done everything, if you weren't able to do this, you're going to understand it less well. But now that you've seen it, I think you're going to understand it pretty well. Okay, so transformation of a graph. Formula. You talk about transformations of a rectangle. Okay, the first transformation that you want to understand is the last one that we're going to talk about in this class. I'll just lay it on you right now. You got a rectangle, it's got a width and a length. This is your width that goes horizontally, your length goes vertically. Okay? I normally use H for height because that's kind of how high the thing is, but H has another meaning. It's your horizontal shift. Okay? That's what you use. Okay? Now, here's the original rectangle. This is a vertically stretched rectangle. We take this rectangle and stretch it out. Right? Now, did we kept the width the same? Should be. It looks like maybe I didn't quite make it as wide. It's still W, right? Width is still W, whatever W is. That doesn't change when we do vertical stretch. Okay? Now, the quick question is this one more or less than twice as high as this one? Is this distance more or less than twice this? How many think it's more? How many think it's less? How many don't think? Well, sometimes it comes at you fast enough. You just kind of go catatonic. Think a minute. Okay? I want everybody to vote. Okay? And I want you to vote for more than twice as much, less than twice as much. Well, it looks like twice as much. Okay? So there are three possible votes. Is this more than twice as high, less than twice as high, or about twice as high? Look at it. Can't give you too much time to think. Okay, now again, if you don't know the answer to the question, you can guess. Okay, flip a three-sided coin. Roll a die. You just want one of a pair of dice. Okay, and figure out how to interpret that. So I want everybody to hold their hand up with their thumb, either up, down, or sideways, for more than twice as high, less than twice as high, or about twice as high. You really want to see this. Okay, so on three, everybody get ready, just kind of practice holding your hand out, but then put your thumb where it belongs and do it at the same time so people aren't telling me what other people are doing. Okay, ready? 1, 2, 3. Okay, let's see. About twice as high. We got some more. We got some less. Okay. Okay. Well, we could measure. I mean, we just do this. Yeah, it's clearly less. But looking at it here, it might look like it's twice as high. Okay. Looks like it's about twice as high as it is wide, but this is a little extra wide. Now, I look here, right there is the height of this one, right? Now, if I go twice as high, I got to go that high again. It's all the way up here. It's clearly less than twice as high. If you actually measure it. So you subject to optical illusions. We had an opinion, and this wasn't a bad vote, actually. It kind of looks that way. But you look closely and think about it, well, it's a little less. So I say it's about 1.6 times as high. Okay? It might be 1.4, it might be 1.5, it might be 1.7. You take a meter stick and measure it and figure it out, but I'm not particularly interested. We make an estimate and we get the idea that this is about that many times as high. So I'm saying now that if this is L, then this is A times L. And what's A? Well, A'd have to be 1.6. If this is 1.6 times as high, whatever this length is, this length has to be 1.6 times. Right? So there it is. So for the picture, if I'm right, K is 1.6. If you think it's 1.5, that's fine. If you think it's 2, that's okay. All right. If you think it's 48, then you're not being reasonable. But that's okay too. At least you know what to do with it. Okay. Now, picture of what we got then is, okay, if we got the x squared graph in this first rectangle, then this would be the ax squared graph. And if this is 1.6 times as high as this, same width, then y is 1.6 x squared. Okay. And if you plug numbers in and make estimates the way we've been doing, if you draw this accurately, it's going to work out pretty close. Okay. Now, what if you didn't have the x squared graph in here? You know, you can draw a bunch of different graphs in a rectangle. There are 5 of them you need to be able to draw right now. Okay. Don't know what the 5 are. First 3, I think, were introduced on the first day. And then 2 more on last Tuesday and 2 more on Thursday. Those are the 5 big ones. We'll construct more, but those are the 5 that you build most of the undergraduate mathematics on. Okay. Now, if you got 2 to the x, then what's the formula over here? Well, it's a times 2 to the x, right? If it's 1 over x, then you draw it in here, stretch everything out. You know, do the same algorithm, you know, just subdivide this rectangle the same way you would this one. But now everything's 1.6 times as far away, or as far apart on the vertical. And you get a times 1 over x, which is 1.6 times 1 over x. And of course, that's just 1.6 over x. Well, that's vertical stretches. That's what you got to know. Then we'll see that, you know, that assignment is actually coming up in open math in a couple of weeks. But we want to see it now so we understand it before we try to use it. Now, the other transformations that you're very familiar with, if you got this box and move it over h units and up k units, okay, this point has coordinates hk. If we move over h and horizontally h units and vertically k units. You move the box without changing its length and its width, then what we would get would be y equals x minus h squared plus k. And we did a lot of that last year. So review that. And that all ought to be pretty obvious. So if we've got a function f of x, we move it h units horizontally and k units vertically. Now here's a graph, okay? Not one of the graphs that we've done, but one that we can build. And here it is with the rectangle moved to the right. I actually made the rectangle a little bit too narrow. It should have been a little wider. So the shape would have been identical. Okay. Now, if this is f of x, this is f of x minus h plus k. Now, if you combine that with a vertical stretch, and where's my board? Let's go back to where we were. How does that fit in with what we did last time? And what we have explained here. F of x is 2 to the x. Now we have not just f of x minus h plus k, which we saw last week, but we have an a in front of it, which vertically stretches. Okay. Now this one isn't vertically stretched because the rectangle is 4. Actually, it is. The rectangle is 4 by 8. You know, if we draw this in a 4 by 4 square well, we'll build on that idea. But there's where your A f of x minus h plus k comes from, and that's something that you should be able to put together at this point. Okay. All right, now. What we did here was we expanded this, and we've got our square here. Okay. Square is, of course, what's bounded by this. This tells me that this rectangle, I call it a square, it's actually a rectangle. This rectangle is how wide? From -16 to -12, your width is 4. Your dimension here is 8. The red dot is down here. If you compare this with the 4x4 rectangle, if it was a 4x4 rectangle, that our parabola would be first off, HK is, okay, what is HK? H is the horizontal coordinate, which is -14. K is the vertical coordinate, which is 24. Here, our function is our basic squaring functions in a 4x4. Okay. So it's just f of x minus h plus k equals this. And this rectangle we get this. I've written that out kind of small. Okay, it's a 4x4 rectangle. HK is -14.24. In the squaring state, y equals try to decide how much to write. I want to rewrite all this. Okay. in this 8x4 rectangle, twice as high. Y equals 2 times the quantity x plus 14 squared plus 24. Okay. Now relate that. It's going to be a little harder to understand this as I'm saying it now, if you aren't up to speed on what we did Thursday. Okay. You're up to speed on what we did Thursday. Well, if you aren't, get up to speed and then take another look at this. Okay. This is why you need to come to class prepared, but it's not that hard. Pretty straightforward, and we'll be repeating it some. Okay. Now, what I really wanted to do and spend most of the time on is start pulling a little algebra into the situation. Okay. Now the algebra is here's where we're at. We think that y equals 27. When x is negative 15.2 or negative 12.7. Okay. Now, those are the estimates we got from our picture, which you can easily construct if you just kind of review a little bit. It's not hard to construct it. And it's not hard to figure out where the labels are because the numbers are pretty easy. Oh, wait a minute, whoa. This isn't 2 because this rectangle is square. No, it isn't. It is 2. Looking at the wrong numbers. I don't know what I'm doing. Just pretend I do. Okay. So, yeah, we think this is a model for this graph. Actually, we think this graph is a model for that function. Let's test it. I'd rather test it with a better piece of coffee. I don't know where I put it. No, there it is. Okay. Well, that is then that y equals 2 times quantity x plus 14 squared plus 24. I'm going to write out differently. 2 times the quantity x plus 14 squared plus 24, which is y. And 27 is y, right? So we can write this as an equation. 2 times the quantity x plus 14 squared plus 24 equals 27. Now, it appears that we're all on screen, and I apologize if you're. Okay, you're getting this in the video. It'd be nice to have it all on screen. Okay, so again, for the benefit of those who've seen it in the video, this is the function that models this curve, or the curve model of this function, if we've done everything correctly. And if we've done our estimate correctly, we see that y is 27 when x has one of these two values. Well, if y equals this and y equals 27, then we can set this equal to 27 because they're both equal to y, right? So this should equal 27. Now I'll say X is approximately equal to this, one of this, because we don't think we really have it accurate to 700 decimal places, okay? That's an estimate from a graph. We're not even sure of having it accurate to 1 decimal place, but I think we're pretty close. Okay, well, how do we test this? Well, everybody got a calculator handy? You got one? Grab it, give you a second. Okay, and if you have your calculator, you can go ahead and use it. You can replace X by negative 15.2, do the calculation. I think this is what you're gonna get, okay? And if you replace it by negative 12.7, I think this is what you get. If you don't have your calculator, just do it by hand. Plug it in and see what you get. At one point, you're gonna have to square something that you probably don't want to take the time to square. But at least do that much. Plug it in and do as much of the calculation as you can. See what you get. Some people don't appear to understand what I mean by replace X by negative 15.2. Okay. Make sure you understand what I'm doing here. If X is negative 15.2, then this becomes 2 times negative 15.2 plus 14 plus 24 equals 27. If X is negative 15.2, then we replace X by negative 15.2. Now, let's just write that 2 times negative 15.2 plus 14 plus 24 equals 27 on 17. A little question mark on that. We don't expect it to come out exactly because we kind of expect that the exact thing is an irrational number with an infinite number of decimal places we can't predict. Okay. We can calculate them one by one if we know the algorithm, which we don't. But we have, okay, well, what's negative 15.2 plus 14? Well, that's negative 1.2. Okay, so we have 2 times negative 1.2 squared plus 24 equals 27, which means 2 times 1.44 plus 24 equals 27. 12 squared is 144, something, a fundamental bit of arithmetic everybody should know. That's okay. If you got to use a calculator, use it. The arithmetic. You multiply that out, 2.88 plus 24 equals 27. We get 26.88 equals 27. So we got a very good estimate, didn't we? Okay. I remember when I did the estimate, I thought it was probably between. Yeah. Okay. Okay. We've got a good estimate. And this thing works. That's the whole thing we're trying to get across here, because people go through a whole pre-calculus course and don't understand that that's what everything means. Okay? So we try to establish it right at the beginning. Now, the other one, you do 2 times negative 14, negative 12.7 plus 14 plus 24 equals 27. And you do the same thing, and you get 27.38 equals 27. Again, we get good agreement. Okay. Now, that's not an exact solution. If we need an exact solution, we can't do it by estimate. The reason for the estimate is that by doing the estimate, we convince ourselves that this represents that graph we constructed. Okay? Now, of course, we can't understand that unless we can construct the graph and do all the labeling and the lines, but that's easy if you just practice it a little bit. Now, the construction, let me just digress to that before we do the exact solution. The construction can be, well, we have to be able to construct these graphs in 2 minutes or less because we're going to construct them in class a lot. We have to do it fast. And we have to know it well enough. And in order to do that, what do you have to do? You got to practice. I said this in the email. I don't know how thoroughly you read the email. You read them as thoroughly as I do, you probably didn't remember anything. Because I don't always remember reading things thoroughly. I miss stuff. And everybody does. But I'm not excusing that. We all need to read emails carefully when they're important, okay? And this is important. You need to practice. And by practice, that doesn't mean sit there with a picture of it and imitate the picture. It means take it, do that a few times if you have to. But then clear everything off, take a blank sheet of paper and construct the dang thing, then compare with a picture. That's how you learn to do it. And you do that repeatedly, preferably every morning and every evening. It only takes a few minutes once you get used to it, okay? Until you can do it efficiently. Now, that was the quiz I was going to give you today. Okay. But when I saw that people weren't doing it, I said, okay, we're going to have to do a little bit of a delay here, which compresses the rest of the course. And that's not a good thing. But with all the delays and everything, we really don't have a choice. Okay. Okay. Number one, you think you got to learn. In this course, you got to practice. Means you got to do the homework and practice a little more if you need to. Now, I didn't tell you how many times to practice this because I don't know how quickly you're going to learn it. Some people pick it up quickly. Okay, a lot of you have the pattern. Everybody seemed to have the pattern a week ago. So you have a basis for practicing. You need to do that because you will have a quiz Thursday. It's going to be a 30-point quiz. Okay, and you got 6 minutes to draw all three of them. Well, the first three graphs. Okay. And then when the test comes, you have to do all five. It won't be timed, but you want to be able to do them quickly so you don't have to spend all day in there with the test. Okay, so you got to practice. You're not going to learn the math unless you practice. I've seen really good work out of this group. Okay, I know you can do it, but you got to spend the time and you got to know what to do, which is basically practice and check everything. Okay, learn to do that, and I think we're going to get some really good results. Okay, well, let's talk now about how you get the exact solution. Solve this equation. Now, before I solve that equation, there's one more thing I got to digress to. Now, there's an assignment due today. Should be in your notebook. You should have a dedicated notebook where you work the assignment the weekend out. Okay. And I will normally ask you to open your notebook while you're doing another quiz and let me take a look at your work so I can get an idea what you need to hear to understand it a little better if you need that. Okay. Now, that assignment required that you know what your version number is. Didn't require that you know your ABC numbers. It required your version number. Remember getting an email with a version number and your ABC numbers? You should have those prominently in your notebooks. You don't have to keep looking on the first page of your note. And you go to the assignment, you click on it, and 100 versions. 7 problems in each version. And what I asked you to do, I think for today, was the first 5 problems. Maybe the first 3, whatever it said in the assignments page, but you got to read the assignments page to know what to do. Okay? If you haven't done that, get on it. Trying to prepare you for what you're going to be tested on. It'll be a 300-point test. Okay? And, you know, that test it's going to be about a third of a letter grade. So if you make a 0 on the test, you've already sacrificed the best part of a letter grade in the course. Now, I'd probably let you take it late, but there's a penalty. Okay? It'll always be available for half credit, but half credit is close to half a letter grade. You don't want to sacrifice that. You want to do that well. You can if you practice. Got it? Practice and do what it says. Show me your work. Then we address things that maybe you don't understand. Okay. Well, also, if you have trouble seeing the board, I'm doing this on Zoom. You got a device, you can see up close. All you got to do is email me and say, hey, I need the Zoom link. Or if I forget, to say at the beginning of class, hey, can you send me the Zoom link? Sure. Send it to everybody. So you have the option of seeing what we're doing on your device. And the camera, it's a good camera, and you get pretty good picture. Okay. Camera's a little temperamental, a little aggravating sometimes, but it's good quality video. Except for that guy that's talking, right, stuff. Okay, now we got this. Now back to this. You understand that what we've done is we estimated the value of X that makes this true. And we find our estimate almost makes it true. Okay, very close. As close as we can expect for a hand sketch graph. I'm proud of that. You know, it actually turned out better than most. Your estimates might be better. You know, if you're more careful, if you're just better at drawing things, better at dividing things up. It might not be as good, but it'll still give you reasonable results. It'll still convince you that this stuff works. Okay, well, now we're going to do algebra. We haven't done any algebra yet. We just plug numbers in and evaluated things. Okay, algebra here. I'm trying to solve for X. What are my options? What can I do to this equation? Okay, I got one response that use the distributive line. Yes, you can do that. If the square wasn't there, you could multiply the X by 2 and the 14 by 2. That's your distributive law. You get 2X plus 28. But this is squared, so you'd have to square this, and you can also do that using the distributive law. Okay? And it's not too hard, but we don't want to go there right now. We will soon. You would end up then with a quadratic equation. This is a quadratic equation. You'd have it in a little different form. And the only way you'd be able to solve it most likely would be with the quadratic formula. And that's coming up, but we don't want to do that today. Okay. So good suggestion. What else can we do? Well, I'm seeing a bunch of blank stares. What can we do with an equation? Well, one thing that you can kind of do is you can do the same thing to both sides. That sound familiar? What kind of things can you do to both sides of the equation? We can't do just anything to both sides. Like I could cross all the numbers out of this equation and I'd get X squared equals blank. That would change the solution. So you wouldn't even have a solution because you wouldn't know what X squared is supposed to be. Okay? Because you erase all the numbers, all you have left is an X squared on this side and nothing on this side. Okay, so you have X squared equals. No more. Okay, so you can't just cross out all the numbers. Okay. Now, well, clearly you can't do that. You know, we can't do that. What can we do to both sides of an equation without changing its solutions? Okay, well, somebody gave me a specific suggestion, subtract 24 from both sides. Is that legal? Well, yeah, you can add or subtract the same quantity on both sides of an equation. So when I say, what can you do to both sides of the equation? One of your answers would be add or subtract the same thing. Okay, another one would be multiply by the same thing, as long as it ain't zero. Multiply by zero, you get 0 equals 0. That's true, but it doesn't give you any information about x. So you really got to kind of review that. I think everybody's understands this. Although, as a class, you did do particularly well on the assessment thing. Okay, I see some real rustiness in the algebra. So that's why that's why we started with the pictures. Okay. We get the pictures down, we figure out what they mean. We understand functions without ever having to use many numbers. The only numbers we've used are just the numbers we put on the graph. But now we're starting to get numbers in an equation, and now we have to start doing some algebra. Okay, well, I think everybody's familiar with the fact that you can add or subtract the same number on both sides. So we do that. We get 2 and x plus 14 squared plus 24 minus 24 equals 27 minus 24. And that tells us that 2 times x plus 14 quantity squared equals 3. Okay, because 24 minus 24 is 0, so we don't have to write anything down here. 27 minus 24 is 3. Okay. Now what can we do? Okay, well, people still want to square this, and that's a valid thing to do, but you're stuck with a quadratic formula if you do, as you'll see later. And we don't need the quadratic formula. Okay, so going to run over just a minute or two here. Almost done. So there's nothing we can add or subtract to both sides to get us closer to x. We subtract 2, well, the 2 is multiplied by this. You don't get rid of a 2 that's multiplied by something by subtracting a 2. How do you get rid of it? Divide by 2. So we'll do 2 times x plus 14 quantity squared divided by 2 equals 3 divided by 2. Well, the 2 divides the 2, giving us 1, and that just leaves us with x plus 14 squared equals 3/2. They're probably going to want to make that into 1.5 to put it into a calculator, but right now we'll just keep it the way it is. So what's x plus 14? It's plus or minus the square root of 3/2. Okay. And now we subtract 14 from both sides. We get x plus 14 minus 14 equals plus or minus the square root of 3/2 minus 14. Now I've got to it can come up here so that x is plus or minus the square root of 3/2 minus 14. So x could be minus 14 plus the square root of 3/2. Or x is negative 14 minus the square root of 3/2. Okay. Now we can take your calculator, do the square root of 3/2, add it to negative 14, subtract it from negative 14. You're going to get something pretty close, -15.2, -12.7, but it's gonna be more accurate. It won't be exact. That's the exact solution right there. Okay. Now, next time you can expect to be given something like what we started with, where you can start the solution and estimate it. Okay. And write out the formula. And then write out the equation and solve it. Now, be explicit with that when I post the assignments page. It can be by this evening. Okay? And be sure you check the assignments page so you know what you need to do for Thursday. In addition, get caught up on everything. Because most of you are